Hello, and welcome to my video on area between curves day 2. So in this video, we're going to take a look at calculating area with respect to y. And let's kind of reference our last video really quick. So if we want to find the area with respect to x, we calculated the area as integral from a to b of top minus bottom. That was the general idea to help us solve this problem, where everything was in terms of x. So everything in terms of x. What I mean by that is like your limits of integration, a and b, those are essentially x values, x equals, x equals. Your function was like f of x minus maybe g of x. So the functions were in terms of x, okay? Now, oftentimes for problems, it depends on the way the graphs work out, but it might be easier to do this stuff with respect to y. And what we mean by that, you can maybe guess, is we're going to integrate, in this case, you'll see it from y value to y value, c to d, and instead of top minus bottom, we're going to do right minus left. So right minus left. It's just like top minus bottom, and you'll notice I'm going to have a dy. So everything is in terms of y. These are y values. This is a y value, okay? This one might be like f of y minus g of y. So it's a function of y, not functions of x's, okay? And you'll notice that in the picture, which you see right here, f of y, g of y, okay? So let's try to visualize why this right minus left works. So if I was to calculate the area for f of y, okay, that would be this calculation. I would be calculating this area right here. All of this stuff from the function all the way to the y-axis. So just like when we do integrals with respect to x, where it goes to the x-axis, when I do an integral with respect to y, it goes from the function to the y-axis. So that integral would be the blue part. So the blue part, so blue equals the integral from c to d of f of y dy, would be that calculation. Now, if I did in red the integral from c to d of g of y dy, it would be this area right here, this area right here in red, and also this area right here, which is negative space, okay? So if I was to subtract those two, right minus left, you'll notice, like for example right here, if I subtract the blue minus the red, I get the stuff in between. And likewise, I would get all of this area. That would be the right minus the left. Now, you'll notice when part of the red function goes in the negative space, it actually turns into addition, which is good because we actually have to add these two areas to get that area in between them, okay? So our formula is essentially this when we're doing things with respect to y. So let's go ahead and practice one. This says to write, but do not solve, an integral that represents the shaded region. So you'll notice you have your right function and you have your left function. Now, why would I do this right minus left? Let's discuss this. I would not want to do top minus bottom because if you look right here, for example, and right here, I have top, bottom, top, bottom, top, bottom. There's 3 different integrals because I have different top and bottom functions. Top and bottom, top and bottom. That would be really hard. Why would I want to do all that extra work to do top minus bottom with respect to x when I could just do this with respect to y, and it's simply I have one right function the entire time, which is this one, and I have one left function the entire time, which is this one. Now, one thing we have to consider also is the intersection points. It looks like the y value is 3 and the y value is -1, but we should always be sure. So I would do like y minus 2 squared equals negative y squared plus 10. I would find the intersections just to make sure, and I want to find the y values because we're going to do this with respect to y. I don't want these x values. I don't care what x value corresponds to this point or to that point. All I want are the y values. So let's just double check this. This is y squared minus 4y plus 4 equals negative y squared plus 10. So I would get 2y squared minus 4y minus 6 equals 0. I can divide the 2 out. And you'll see I'm going to get y minus 3, y plus 1 equals 0. So y equals 3 and negative 1, which is what we thought they were, but we should always confirm those intersection points just to make sure. Okay, so now we're going to integrate. Notice I'm using y value, negative 1, to y value of 3. And it's the right function minus the left function. So negative y squared plus 10 minus y minus 2 quantity squared dy. And that's it. That would be our solution. This is the right minus the left. And we're using y values for our limits of integration. That is critical, not using x values. All right. This one says to determine the area. And it's kind of laid out for us. It even says right function, left function. And you'll notice this one is on the right the entire time. This one's on the left the entire time. If I tried doing top minus bottom, it'd be really, really complicated to do this because I have a top, a bottom, and then here it kind of flips again. Okay, so we don't want to have to do that. Keep it simple. If I can get one integral with right minus left, that's what I should do. So you'll notice your functions are in terms of y, so it kind of gives it away that maybe you want to do this in terms of y. Okay, and you'll notice we have our y values, negative 2 and 2. We don't care about the corresponding x values at all, so we're going to integrate from negative 2 to 2, right minus left. So y cubed plus y squared plus 8 minus y cubed minus 4y dy. We'll simplify this, negative 2 to 2. The y cubes are going to cancel because you're going to have a minus sign there. I'm going to get y squared plus 4y plus 8 dy. Find the antiderivative, 1/3 y cubed plus 2y squared plus 8y from negative 2 to 2. We would plug these in. We would get 8/3 plus, let's see, 4 squared times 2 is going to be 8 plus 16 minus, if we plug in negative 2, we're going to get negative 8/3 plus 8 again minus 16 here. Okay, and then we would go through, obviously, simplify things, combine all this and get one final answer, but we'll go ahead and just leave it there. We've applied the FTC and we're in pretty good shape. Okay, next up, we have number 2, in which we do not have a sketch drawn for us. We're going to want to go ahead and draw a sketch for ourselves, probably to figure out, which one is the right and the left functions if we're not sure. So, what is this going to look like? Okay, this is a parabola. So this right here is a sideways parabola, opening right, I'll just say parabola opening right with vertex of negative 3, 0. Okay, goes back to your conic section days in algebra 2. So we're going to have our vertex here, let's say this is negative 3, and it's going to go rightwards, and we don't need to be super exact, just get a rough sketch of what this thing looks like. Something like that, okay? This one over here, the next one, is a line. So, let's see here, this is a line, and we might want to solve for y, so it's in a form that we're kind of comfortable with. So y equals x minus 1, that would be our line. So that would be, negative 1 here, slope of 1. So go like this, just kind of follow that general pattern, up 1 over 1, up 1 over 1, up 1 over 1, okay, and something like that. Now, we can see very easily that this is the right function, and this is the left function. What are some key things we have to find, though? We have to find this intersection point and this intersection point. These corresponding y values are critical to us for writing our integrals. And then we can calculate our area. So how are we going to do that? We want to set the two functions equal. So this one we probably actually want to solve for x because the first one's already solved for x. So let's kind of go back. X equals y plus 1. And we set these equal. So 1/2 y squared minus 3 equals y plus 1. So 1/2 y squared minus y minus 4 equals 0. Might want to multiply by 2 to get rid of the 1/2. So y squared minus 2y minus 8 equals 0. Y minus 4 y plus 2 equals 0, so y equals negative 2 and 4. So we know now that this y value is negative 2, and this y value is 4. Critical for us to find those. We don't care about the x values because we're doing right minus left, so everything's in terms of y. So which functions do we actually want to use? We want to use the ones that are expressed as x equals stuff with y in it. So we want these two. And we've already assigned our right and our left. Our right is the line, our left is the parabola. So we're going to integrate from negative 2 to 4, right function, which is y plus 1, minus left function, 1/2 y squared minus 3 dy. And this one said to find the area. I'm not going to finish the entire problem. I hope you guys don't mind. I think we've done enough integration where you probably can handle this, but I'll simplify a little bit. So negative 1/2 y squared plus y plus 4 dy. And then you would want to find the antiderivative, plug in the top, plug in the bottom, subtract them. You've done it a bunch of times, right? So we'll leave that one as is. Okay, another one that we have to be able to sketch a picture for. So let's go ahead and draw this out. So we have a line. So this is a line, right? Intercept of negative 2, so 1, 2, and slope of 1. So maybe we have a point here, point there, point there, point there, point there, point there. You get the idea. That's going to be our line. Then we have the square root function, which is a sideways parabola. It's going to go like this. It's going to go like that, somewhere like that. Okay. And we're trying to find the area between these curves and y greater than 0. So that would be this line right here. So what is the region that is bounded by these two? It is this region right here. Or by these three, sorry, by these three things. Okay, so you'll notice we're not going all the way down to negative 2. We're stopping at 0. So my y values are going to be 0, and then whatever this intersection point is. And we should figure out what that is. Okay, so I want to find the y value, which means I probably want to, in this case, maybe go ahead and solve for x, because we're going to need to anyways. So x equals y plus 2 for that one. This one is x equals y squared. Why am I doing this? Because I'm choosing to do right minus left. If we did top minus bottom, we would have to set up a new integral right there, because the red is on top, the green is on bottom, and then the red is on top, the blue is on the bottom. That would require two separate integrals for that calculation. We don't want to have two separate integrals if we can avoid it. Okay, so if we just do right minus left, we're in pretty good shape. So we know we're going to integrate right function, which is the line, y plus 2, minus the left function, which is y squared. Okay, the last piece is we know this is 0. We're starting at 0, but we don't know where we're ending. That's our question mark. So we have to set these equal. Y plus 2 equals y squared. So y squared minus y minus 2 equals 0. Y minus 2, y plus 1 equals 0. So y equals 2 and negative 1. Now negative 1 is actually not a solution, because if you plug that back in up here, negative 1 equals root x, that's not possible. You can't have negative equal a radical. So that's not actually a solution. It's just y equals 2. And it kind of looked like that in our graph that this is actually 2. And there we go. We would then, go like this. And we might have negative y squared plus y plus 2 equals 0. Not equals 0. dy. And then we would find the antiderivative, apply the FTC, and we'd be good to go from there. Okay, so I'll kind of finish this, but not really fully finish it. So our antiderivative, and then you'd apply the FTC where you plug in the top, plug in the bottom, and then that is going to be your answer. All right, so this one, if we did, just to clarify, if we did top minus bottom, here's what would happen. So we have to think in terms of x. So with respect to x, okay? I showed you it would kind of split right here. We have to calculate essentially this area separate from this area right here. Okay, so we'd have to have two separate integrals. We would go from 0 to 2, because this x value is 2 right here. We would go from 0 to 2. The top function is red, so that would be square root of x dx. The bottom function is just x equals, or y equals 0, so we don't have to subtract anything, plus the integral from 2, and then this x value where they intercept is actually x value of 4. 2 to 4, top minus bottom, so red minus blue. So that would be root x minus 2 dx. So you see how this would be a much more complicated integral to solve. We want to avoid that, but it would give you the same answer in the end, okay? So that's actually going to be it for this video. We'll finish some more examples in class. Thank you for watching. If you have any questions, please let me know.